Good to have everybody back. Sorry I can't be with you today. We're going to be talking about, over the course of several videos, a couple of derivations from the ideal gas law. And I just want to remind you that about two classes ago, we were introduced to what I consider to be the most powerful gas law that there is, the ideal gas law, PV equals nRT. Well, there are a couple of ways that we can arrange this law such that it can do some pretty unique things and calculate some unexpected things. And so, in this first video today, what we're going to do is talk about how we could use the gas law itself, PV equals nRT, to calculate something like molar mass, something that we usually have to rely on the periodic table to help us with. And so we're going to talk through kind of a hypothetical. If you go to the grocery store or a gas station and you purchase just a standard lighter, the gas that's inside one of those lighters is butane. And butane has the formula C4H10. And if we go to the periodic table with C4H10 and we calculate its molar mass, it's going to be, four times the molar mass of carbon, which is 12.01 grams per mole. And it's going to be 10 times the molar mass of hydrogen, which is 1.01 grams per mole. If you add those together, you get its molar mass. And so let's do that. If we plug that into our calculators, 4 times 12.01 plus 10.10 comes out to 58.14 grams per mole. And so pretty easy to calculate that. But I want you to imagine a specific scenario where we only had access to an experimental setup, but we did not have access to a periodic table. And let's say we wanted to find the molar mass of C4H10, but we couldn't do it using the periodic table. We had to use some experimental method instead. Well, I'm going to show you today what you would need to know in order to calculate that molar mass and um, essentially a method for doing that. So, the first thing that I want to talk about is essentially what is the formula for molar mass to begin with. So, if I look at molar mass, we usually designate it by a capital M, and we find that its units are in grams per mole. So we can think of molar mass as mass over moles. Okay. Well, if you think about what our ideal gas law is, it contains pressure, it contains volume, but it also contains moles. And so we could rearrange this equation if we wanted to, such that let's bring moles to the left-hand side. Okay. And we get something that looks like this. And then let's do one more rearrangement. Let's divide both sides by molar mass. Okay, when we do that, what we're left with is moles is equal to mass divided by molar mass. And it's kind of hard for you to tell from my terrible handwriting, but that is a lowercase m over an uppercase M. Okay. So I want to make a substitution, if you will, into our equation for the ideal gas law. Instead of keeping PV equals nRT, what if we substituted what we just found for moles in for that N right there. And so we might get something that looks a little bit like this. PV equals little m RT divided by big M. Or another way of saying that, pressure times volume equals mass times R times temperature divided by molar mass. Now, I can rearrange that if I want to solve for molar mass, and that would look something like this. Molar mass equals MRT over PV. So we have an equation now, and that equation, even though it's really just the ideal gas law or a variation on it, that equation is often referred to as the molar mass equation. And it's a way that we could use experimental data to find the molar mass of a gas. And you'd only need to have really four pieces of information to find that molar mass of a particular gas. And I've got that listed right here. You would need to know the mass of the gas that you were measuring. So you would have to find that in grams. You would have to know the temperature of that gas, and you would find that in Kelvin. You would have to know what pressure that gas is under, and that would be in atmospheres. And you would have to know its volume, and that would be in liters. But if you knew those four things, you could solve experimentally for the molar mass of a gas. So we're going to pause right here in the video, or actually, we'll create a separate video in which I give you some experimental details on a hypothetical experiment in which we are going to try to calculate the molar mass of C4H10. But the biggest thing that needs to be in your notes right now is we have a new equation or a new variation on the ideal gas law in molar mass equals mass times R times T over PV that's going to allow us to do that experimental determination. That's kind of the big take home message, so to speak. Okay, I'm going to stop right here. When I come back in the next video, we're going to have a setup for our problem in which we're trying to discover what's the molar mass of butane, but do it experimentally instead of using the periodic table to help us. See you then.